Okay, now we're going to be starting the SQL presentation. So once again, I'm Drew from HS Navigator. So here's a table of contents which covers basically all the topics that we're going to be going over today. We're going to start off by answering the question, what is SQL? And like the basic ideas of SQL, the definition. Then we'll be looking at the idea of structured data, which is what SQL queries through and what we use SQL on. Then we'll be looking at different data types, which is an important idea in SQL. Then we have these three abbreviations, DDL, DML, and DQL. And for now, we don't have to worry about what they stand for and what they mean until we get to those topics in the presentation. And then finally, we'll be going over joins and grouping, and we'll have a live demonstration at the end. And while I'm going through this presentation, if you have any questions, you can put it in the Q&A chat and we'll answer them. So first off, what is SQL? SQL stands for Structured Query Language. It is a language used for storing, manipulating, and retrieving data stored in a relational database. So when you have a database that's full of millions and millions of different data points, it's almost impossible for a small, simple program or for one person to individually go in and retrieve the data that they want. However, SQL has the ability to do that, and it's also pretty user friendly and easy to use. This is what people like data scientists and other people that work with huge amounts of data use to quickly get specific information that they need. Why use SQL? SQL will query the database in a variety of different ways. It has lots of different commands and functions that you can use, and you can pick out specific ones that suit your needs. It requires little coding knowledge. Most of it is simple English, and it's all very easy to understand. You don't need to be an advanced coder or computer scientist to use SQL. And it's a standardized language that works across different databases. So if you have different tables, the same SQL code can be copied and pasted, or with very small manipulations, can be used on another data table because it is a universal standardized language. Now we'll be looking at structured data. Structured data has a well defined structure. It is data stored in the form of rows and columns. It is the foundation of relational databases. It's easy to access and query. It ensures the security of data is easy. It maintains data with things like insert, update, and delete very easily. So here's an example of structured data. Here we have a table with different types of information. We have different columns and fields, such as a ID column, a name column, employee age column, employee salary column, and join date column. Then we have different rows or records. Each row goes horizontally, and it goes through one row goes through every single column. For example, if we look at the third row that's highlighted, in the ID column, the row has the number 3. In the name column, it has the name Jimmy. In the age, it's 27, and so on. And then we have different values stored in each cell across the whole table. Now we'll be looking at data types. Data types comes in various types, and here are some examples of popular common data types. We have char. It stands for character, and it just stores a single character, such as the letter A. Then we have varchar. It stores varying lengths of characters, text of varying lengths, such as California. Then we have integer. Integer stores basically integers. It cannot store decimals. It'll be a real number but no decimals. So things like 5, 3, 0, -100, 10,000, numbers like that. An example of it is 1. Next we have double. These are numbers with decimal values. They can be positive or negative. and an example is 5.25. Then we have date. A date stores a day, month, and year. For example, 22/7/10. Then we have the timestamp. A timestamp is basically a date with a specific time that gives hours, minutes, and seconds. For example, 22/7/10, and then for the time 13/21/12. And other examples include Boolean, which stores data that's true or false, one or zero. And there are other things like text, tiny int, blob, etc. So when you're defining a field or a variable or things like that, based on the type of data that you want to store in that field, you will pick one of these different data types. Data types define a kind of operation that can be performed on a field. For example, if your data type is integer, you can run things like math operations. For example, sum and average. And you wouldn't be able to run these functions, these math functions, on a varchar or a date. But then on a varchar, you could do things like text lookup, and on date data types, you can look up things like monthly and yearly trends and date operations. Collection of organized data in tables. So this shows different tables with fields and how they're related to each other. Our biggest table over here, employee, includes employee name, job title, phone number, salary, department ID, and project ID. And this shows how these tables are related because over here we have another table that consists of project ID and name. So based on this table, we can pull out a specific project ID and look that up in this table and extract a project name from that. And then in the departments table, we can pull out a specific department ID from this table and look up the department name for that. Data definition language. This is the first abbreviation that we're coming across. And data definition language is used to create and modify the structure of database and tables. So it's the starting point where we basically create and establish the data that we're going to be using. So one of the main functions we'll be using is the create function. So create will basically just make a new table, and we'll be defining the properties of the table within this function. So we're going to start out with create table, and we're going to give the table a name. In this case, we named it sales table. And then we're going to open and close parentheses within which we will put our different columns. Over here, we have the first name, the first column name, text ID, and then we have the data type int, and then primary key and not null. What primary key does is it makes sure each item is unique and they don't repeat, and it has other properties, but for now, that's all we'll be focusing on. And not null basically makes sure that any row in that column is not empty. The word null means empty or like no value. So not null, make sure it's not empty, and every row of the column has a value. Next, we have another column called, and we separate columns with commas, as you can see between each one. Next, we have a column called sale date, and then the data type is date. So we will only be allowed to store data with the data type date within this column. Then we have product type, which is our next column name, and it has varchar 25. So that means we can have characters of varying lengths up to 25. And that is the only type of data we'll be able to store in that column. Next, we have item quantity with data type integer, and we have item price with data type decimal 10,2. And what this 10,2 does is it allows the decimal to have a total of 10 digits with no more than 2 digits after the decimal. And this is the table that we have just defined with specific data types in each column. Next, we'll be looking at modifying. So we can do things such as adding and removing columns, modifying column types, and renaming table columns. And there are other things that we'll be looking at in the upcoming slides. So we can use the alter command to start modifying a table. So alter table, sales table, which is the name of the table, basically selects the table that we're going to be changing. Then we have the add function, which is going to add a new column. And then we name the column item revenue. And then we give the data type of the column, decimal 10 which once again allows decimal values to be stored with up to 10 digits total and no more than 2 digits after the decimal point. So that just creates a new column at the end with that name and that data type within the sales table. But then we can also modify an existing column. For example, if we spelled revenue wrong and we want to modify that, we can use the alter table command, select the table once again, sales table, and now we'll be using the change function. And now we'll be writing what we want to be changing, which is column item revenue. And now what do we want to change it to? We want to change the item revenue spelled correctly, and maybe you want to add another decimal point and make the number of digits longer. So we'll be using decimal 12.3. So now we have a new name, item revenue spelled properly, and it can now store data with decimals up to 12 digits and no more than 3 after decimal place, as opposed to previous 10 digits and no more than 2 after decimal place. And as you can see in our final table, we created a new column and updated it. So now it's item revenue with this property. So now we'll be looking at table copy. So this basically creates a copy of an existing table, and it has various different uses. You can use the create table function, sales table copy, which is the name of the new table that we'll be creating. And then the like function will make a duplicate of an existing table. And then after the like, you write the name of the original table that we will be duplicating, which is sales table. And then the drop function basically removes a table from a database. So if we want to remove the sales table copy from our database, we're just going to use a drop function, drop table, and then the name of the table we'll be dropping, which is sales table copy. And all of the commands that I'm referring to are pretty common, but then in some databases, the syntax might be slightly different, but this is the overall idea. Next, we'll be looking at renaming tables. To rename a table in a database, we'll just use a rename table function. So as you can see, if we want to rename sales table to sales data table, we can just do rename table, sales table, and then use a to function, and then the new name. So that's pretty simple. And then now we'll be looking at DML, which stands for Data Manipulation Language. It is used to add and update data within the tables in a database. So let's look at insert. If we want to insert a new row to an existing table, we'll use the insert command. So as you can see, we'd already established this table earlier with these columns, but we had all the rows empty. We didn't have any information within the columns. So now we're going to be adding rows. So we'll use the insert function into sales data table, which selects this data table. And now we'll be adding the values by writing the word values and opening and closing parentheses within which we'll enter the fields for each column. And now we'll start off with the first column. Our value for that will be 1. And then to separate the first column and the second column and separate each own column, we're going to be using commas. So 1, and after we put a comma, it's indicating that we're moving on to the next column. Then we put the date, which is 22/7/10. And then we put another comma, which means we're moving on to the next data type. We have Xbox, comma, then we move on to item quantity, 2, comma, item price, comma, item revenue. and then a semicolon indicates that we are finished with that row. And then we can insert as many rows as we want. So we can insert another row into the same table, and then with values 11, and then a comma, 22, 7, 11, comma, PS5, comma, and so on. And then as you can see, that has been added to our original table. Next, we'll be looking at update. We can update the value of a row or multiple rows. So we can write update sales data table, which once again selects the table that we're looking at. And then what we want to do is written in here, set item quantity equals 3. So we'll be making the item quantity equal to 3, and we'll be making the item revenue equal to 449.97. And now we won't be doing this for every single data in our table. If we want, we can put in a filter like this one by using the word where. So we'll be doing this function where text ID is equal to 1. So over here we can use comma to put multiple different like new field values, and then once again use a where for a filter. And you can also have multiple conditions for your filter, but over here we only have one. So then as you can see, it looks at within this table, sales data table, we're looking for any row with text ID equal to 1. And as you can see, this has text ID equal to 1. And then within this row, we will be updating item quantity to 3 and item revenue to 449.97. Now we'll be looking at removing or deleting a row or multiple rows from a table. We can simply use the delete function. We can do delete from, and once again the table name to select the table, and then we'll be filtering out only rows with text ID equal to 1. So as you can see now, because we have selected all rows with text ID equal to 11 to be deleted, our text ID 11 row is deleted, and now we only have the row with text ID equal to 1. Now we'll be looking at DQL, data query language. It is used to retrieve data from tables, and this is where users spend a majority of their time. DQL select, the basic select statement structure. So you can write select and then a list of columns from table name, where, and once again a filter after where, and order by the list of columns. So if you want to retrieve everything from a table, we use the asterisk. And the asterisk is a special character that basically is a short form for every single column within the table. So instead of, if you wanted to select text ID, sales date, product type, item quantity, item price, item revenue, and the whole table, instead of writing out text ID, comma, sales date, comma, product type, and so on, you can simply use the asterisk, which is a shortcut for selecting every single column. So over here, we want to do that. So we're going to write select asterisk, and then from which table? From the table sales data table. And that will return, as you can see, the entire table. Next, we'll be looking at retrieving the total number of rows. So we can do select the count asterisk, and that's it basically returns the count of rows, total row count, and then from the name of the table, which is data table, sales data table CSV. And then as you can see, it returned total row count is 56. Now, if you want to retrieve specific columns from a table, you can write select sale date, item quantity, or the whichever columns you want to retrieve. In this case, it's sale date and item quantity, and then from the name of the table, sales data table. And then our output, all the rows and all the values of only sales date and item quantity. Now we'll be looking at select. We can retrieve specific columns from the table ordered by item quantity. So let's say we want to select sale date, product type, and item quantity, which we separated by commas over here, from the sales data table. And then while outputting it, we want to order them by item quantity, descending. So we can simply write that after the order by. And then as you can see, we got our 3 columns with all our data. However, it's sorted by descending item quantity. It's going from 11 to 10 and so on. So let's say you want to retrieve specific columns from the table for Xbox products only. So we'll be filtering out only Xbox products using the where statement. So we'll select sales date, product type, and item quantity once again from the table, sales data table, where product type equals Xbox. And now as you can see, once again, we got all our information, but only for the items with Xbox product type. Now we'll be looking at the select where clause. The where clause is used to filter the results. It supports various conditions and operators, where product type equals Xbox is an example, where product type like XB percentage, which means it just needs to contain the letters X and B, and you can manipulate that to do a lot of things. Where sales date, you can use the between function. If the data type is date, you could write between 2272 and 22710. Where item quantity is greater than 2 and product type is equal to Xbox. So in this filter, the and statement requires both of the conditions to be true. So if either one of them is false or both of them are false, then you won't be seeing that row in the results. Next, we have the or statement, where product type equals Xbox or item quantity is less than 5. So for this, either one needs to be true. So that means that your results will include all of the fields with Xbox and all of the fields with item quantity less than 5. The only way it will not be in the results if both sides of an or statement are false. Next, we'll be looking at the in, where product type is in Xbox, PlayStation 5, and then we have not in, where product type not in Xbox and PlayStation 5. So basically, does it include Xbox and PS5 or does it not include Xbox and PS5? Next, we'll be looking at select limit. Retrieve only a specific number of rows. Select date, product type, item quantity from sales data table, where product type equals Xbox. And now we'll be putting limit 10, 5. So this limit is showing that we'll only be getting 5 rows starting from the 10th row of the results. And as you can see, that is filtered out right here. Now we'll be looking at joins. A join clause is used to combine rows from 2 or more tables based on a related column in the middle. And there are different types of joins that we'll be looking at soon. But here's the overall idea. We have 2 tables over here, orders and customers. Orders includes values for order ID, customer ID, order date, and revenue. And then customers includes customer ID, first name, and state. As you can see over here in the orders table, we have customer ID, and over here in the customers table, we also have customer ID. So we can overlap the customer ID to combine the tables, and then we can add new, and then we can combine the extra columns together. So as you can see in this new table that we just formed, we have customer ID overlapping, and then we have all the other columns separated, but merged into one table. So now we'll be looking at inner join. So as you can see, inner join returns records that have matching values in both tables. So over here we have orders and customers. And once again, within these 2 tables, the only matching field is customer ID. So then over here, after we merge the tables, we have order ID, customer ID, another customer ID, order date, revenue, name, and state. And as you can see, we don't have all of the um, rows. We only have the rows matching with matching information for the overlapping section, which is customer ID of 2 and customer ID of 4. As you can see, even though orders has customer ID of 3, there is no 3 within the actual customers table. And even though the customers table has customer ID of 5, there is no order of 5 in the orders table. Customer ID of 5 in the orders table. Now we're going to be looking at left join. It returns all the records from the left table and the matched records from the right table. So once again, we're starting off with the same table, but we're going to be prioritizing the left table over here. So as you can see, after we merge it, we're going to have customer ID of 2, 3, 4, and 3, which is the entirety of the left table. But then we're only going to be looking on the right table, we'll only be getting information that is overlapping with the left table. So we get customer ID 2 and 4 because they're both present in the left table. However, customer ID 5 is not present in the orders table, so that row will not be present in our final merge table. Now we'll be looking at right join. That's basically the opposite of left join. We'll be focusing on the right side table, which is the customer table, and we'll be prioritizing based on that. So as you can see, because it's a right join, all of our information from our right table is here. We have customer ID of 2, 5, and 4. And then on the left table, we'll only be getting information that's overlapping once again. So that's why we have a 2 and we have a 4. However, as you can see, in the original orders table, there was a customer ID of 3 and a row for that. However, because it's a right join, that row will not be present because there is no customer ID of 3 in the right side table. And then this is the final table that results from that. Now we'll be looking at the full outer join. The full outer join returns all records from both left and right tables. So as you can see, we have all the information with all the customers from the orders table, 2, 3, 4, and 4, 2, 3, 4, and 4, with all of their row information. And from the right, we have customer ID 2, 5, and 4, 2, 5, and 4. Everything is present here once again, and all of their information is present over here. So here we're not filtering out any information. We're not being biased to the left table or the right table. We just have all the information present in different rows. And in all of these tables, some of the blocks have been left null if no information corresponding to the first table is available in the second table, or if no information in this second table corresponding to the first table is available. Now I'll be looking at the joins query syntax. So first we can use field names that use table aliases as a prefix. As you can see here, we can select those such as order ID, O customer ID, and so on. From order, we'll use a from to write from orders O. Now we'll be using the inner join. We'll be looking at customer C, and then we'll write on O customers ID equals customers ID. And you can have more fields added to the join condition, but for now we'll be using this one. And then we'll use a filter where C.state is equal to New Jersey. And then instead of inner join, you can say left join, right join, or full join, or outer join. Whatever is required for this scenario. Now we'll be looking at unions. The union operator is used to combine the result set of 2 or more select statements. So if you can use a union to combine these two in this example. First, we'll be starting off by selecting product type from the table sales data table CSV, and then our filter will be where item quantity is greater than 5. So that'll go into the sales data table and return all rows from the product type column if the item quantity is greater than 5. And then our second our second statement will be select product type, which is once again getting the same column from the same table, sales data table CSV, but our condition is different this time, where item revenue is greater than 500. And then we can, because these two are similar and we would want to merge them, we can simply use the union statement and combine both of these statements to give us one output. The union operator selects only distinct values by default. To allow duplicate values, we have to use the union all. And over here, as you can see, our results include both of these combined into one output product type, which has PC, PlayStation 5, Nintendo Switch, and then Xbox. Now we'll be looking at intersect. The intersect returns only common rows returned by the two select statements. So for example, if we have the same two statements at the top and the bottom, and we want to intersect them, it is similar to inner join, where it'll only return items with overlapping and similar outputs. So in this case, we only got PC, Switch, and Xbox, but we did not get PS5. Now we can look at the group by function. The group by statement allows group rows that have the same values into rows with unique values from a column. So for example, we have a table over here with ID and fruit. We have ID 1 for apple, 2 for orange, 3 for apple, 4 for banana, and 5 for orange. Then if we want to group by the data field of fruit, then we will see that we will only have unique values in this new table that formed. We have fruit with apple, banana, and orange, nothing duplicating or repeating. Then we can group by is usually used with an aggregate function such as min, max, average, sum, or count to calculate the information for each of the groups. So for example, we can use the count function over here while we're grouping by fruit. And as you can see, even though our new table has only unique values for fruit, we can also get the count or the number of times this appeared in the original table. So as you can see, there were 2 apples, which is why the count is 2, 2 oranges, which is why the orange count is 2, and just 1 banana. Now we'll be continuing to look at the SQL group by. We can use the sum SQL function over here. Select product type, sum of the item quantity, total item quantity, from the table sales data table CSV, and then group by product type. So then as you can see, the product we don't have any repeating product types. We only have PC, PS5, Switch, and Xbox, each only repeating once, because once again we have grouped by those columns. And then we're getting the sum of their total item quantities. So this makes it much easier to read than like 100 different PlayStations, 100 different Xboxes, and PCs all in one table. And now we have another group by example. So over here we can use multiple functions within one statement. So we could select product type, the sum of the item quantity, which we will be storing under the name of total item quantity, and then the average of item revenue, which we will store under the name of average revenue, from the table sales data table CSV, and we will group by product name. So once again, for the syntax, if we use a SQL function, a math function such as sum and average, we'll write the math function we're trying to do, on which field we're trying to do it, and we'll give a name for the column where we'll be storing the values. So sum of item quantities, and we'll store under the name of total item quantity over here. And then once again, we're grouping by product type. So we only have 4 products now. We don't have any repeating products over and over. and this shows the total quantity of PCs. So we have 103 total PCs, 117 total PlayStations, 52 total Nintendo Switches, and 55 total Xboxes. And then over here, we can see the average revenue. 778 for PC, 878 for PlayStation 5, and so on. And the average revenue can give us a lot more insight on our data instead of simply looking at a bunch of PlayStations with or a bunch of PCs or whatever we're looking at with so many different numbers ranging over a variety of prices. Now we can group multiple fields within the one group by statement. So we can select product type, item quantity, the sum of the item revenue under the name of total revenue from the table sales data table CSV, and our filter where product type equals Xbox. And then we can group by multiple fields in this case, product type and item quantity. So as you can see here, because we group by product type and item quantity, our first of all, our filter only got Xbox in our results. So as you can see, we only have Xboxes here, and then we'll be grouping by this, and item quantity will also be grouped. So that's why we're going like 2, 3, 4, 6, 8, 10. And then our total revenue, once again, is the sum of all the revenues from this row. And now we'll be moving on to our live demo of SQL. Okay, I'm now gonna share my screen for the live demo. So if you want to write code in SQL, you have a variety of different options for you. But we have this first option, ApacheFriends.org, and this is free to download. And I already have this installed. I'm using MariaDB. I already have this all set up for the live demo, and this is what I'll be using. But you guys don't have to download it right now. You can just watch along. And if you want later, you can download this, set up MariaDB from ApacheFriends.org. Or you can also go to SQLitebrowser.org. This is also another free tool available, free to download if you also want to code in SQLite. So those are two good starting points. So now we'll be getting into our live demo. So this is where I'll be coding our SQL for today. for in our HS Navigator demo file that I've saved. And I have a bunch of SQL commands that I already wrote out, saved on another document that I for this demo, which we'll be using. So here's the first command that we have, which will, and basically we're going to start off by creating a table. We're going to create a table with the name of sales table. And once again, these are the different functions that we have. And over here, you can see we have text ID with int, sales date with data type of dates, product type with variable character lengths up to 25. And as of now, we have 0 rows selected within our table. We just created a table with the different columns, and we now have to enter information. But before that, we're going to be adding another column to our data. So I'm going to get that from my document and add it here. So we're going to be modifying the table sales table and add a new revenue tab. So now, as you can see at the bottom, we have item revenue added as a new column with decimals going from up to 10 digits and no more than 2 after the decimal point. Now we're going to change the column, as we saw before, by correcting the spelling of item revenue and changing the decimal requirement to up to 12 digits and no more than 3 after decimal point. And as you can see, we successfully updated it within the table. Next, we'll be looking at how to create a copy of the table. So this can be used for doing things like backing up. And over here, we'll be creating a new table called sales table copy and using the like function to make a duplicate of our original table. As you can see, we have another table called sales table copy, which is a duplicate of our original sales table. And now let's say we want to delete sales table copy from our database. We can simply use a drop function, table, and sales table copy. Now, as you can see, we have successfully deleted the copy of sales table copy. Next, we'll be going over the rename function that we went over, rename sales table. And as you can see, it's now renamed to sales data table. And now we're going to start giving actual information into our columns. We have only created a table and established column fields for it, but we don't actually have any information within them. So now we're going to be adding 2 rows of information into our columns. So as you can see now, we have 2 rows of information with Xbox, PlayStation 5, quantity, and price, etc. And we did select from sales data table to output it. We're going to be updating our records. So where text ID is equal to 1, we're going to make the item quantity equal to 3 and revenue equal to 449. Only where text ID equals 1, which is our filter. So as you can see, the location where text ID was equal to 1, our item quantity has now been updated to 3, and our revenue is updated to 449.97. And let's say we want to delete a record. As you can see right now, we have a row with text ID 11, and let's say we want to remove that. So we'll delete all rows from sales data table with the condition text ID equals 11. And now, as you can see, we have deleted the row with text ID 11. So now we're going to be looking at the row count. And as you can see, we have 28, 23 rows in total. And that is referring to this table, sales data, which is this is not the table that we originally created. We're now working with this another extremely large database with a lot of information about products that have been sold. So now we're going to be trying to get a specific list of columns from our extremely large database. Sales table. So as you can see now, we're going to select the sales data table, which is our new table with the large database. And we'll be selecting order date, city, and sales. And as you can see from that huge database, our SQL command has only brought out the information that we asked, order date, city, and sales. Now we're going to be using the order by function, as we went over before. We're going to use we have two fields within our order by. We're going to use order date and city descending. So as you can see, we have it sorted by order date and city, with city going in a descending order based on alphabet. And our order date is also sorted. Now we're going to be selecting order date, city, and sales columns from the table only if the status is equal to shipped. And then once again, we're going to order it by the same fields. But basically the new thing we're looking at here is the condition from the where statement, where status is equal to shipped. So as you can see now, these are only showing rows where the status is shipped. If the status is not shipped, the row is not a part of our output. Now we'll be using the AND operator, the of operator. Okay, so over here, as you can see, we're going to look at the sales data table, and then we have the AND operator for our function, for our condition filter. So as you can see, status must be in process, and the operation date must be, the order date must be 2005-5/30. So as you can see now, both sides of the if statement must be true for it to be a part of our results. And there only is 7 total of those now. Now we're going to be using the like operator, and we're going to look for cities starting with M. So now our new filter has city like M percentage, which basically the percentage basically means any letters, any number of letters. So we're looking for cities that start with the letter M and have anything after that. So as you can see, we only have cities starting with the letter M now. Now we're going to use the in statement. So once again, we're selecting these columns from the sales data table, and their condition and where is city is in Boston or San Jose. So as you can see, only cities that are Boston or San Jose have appeared. Now we're going to be using the opposite, the not in function. So we'll look at the same condition, but use a not in function this time. So we're looking for cities, and we use a not in function for Boston and San Jose. So as you can see now, we'll get every single city except for Boston and San Jose. Now we're gonna be using the and between function all together. So now you're going to see how it can start getting complicated and we can add multiple different functions in one statement. So we have the city in Boston or San Jose, and order date is between 2004-41 and 2004-531. So for it to be a part of our result, it must be in Boston, San Jose, and the order date must be between the given fields. Both sides must be true. Now we're going to look at the limit. So as you can see, we have a limit from 4 to 15 now. So it'll show 15 records starting from the fourth record. And as you can see, so now with our filters, it'll only start showing 15 records after our fourth record. Next up, we're looking at inner join, which is one of the join types that we looked at. And think back to the Venn diagram that we showed in our presentation. We have inner join on p dot product code is s dot product equals s dot product code, and then we have where s dot year ID is 2003. So as you can see now, we have a joined list, a joined table with our specific department. Now we'll be looking at left join. So as you can see, it's all based around our left table. On the table on the right, if information is not available for the fields based on the left table, it'll be left as null, which basically means it's blank and no information is available. And some information might be left out of the right table if the corresponding information is not present in the left table. Now we'll be looking at group by, which shows the total sales for each city. Because now we're going to start grouping by city, and we'll take the sum of the sales for each city under the name of total sales. So as you can see, we've grouped each city together, so there's no duplicate cities, and we have the sum of the sales within each city. So now we're going to select a variety of things, including the sum of sales stored under total sales, the average sales stored under the name of average sales, the sum of quantity ordered stored under the name of total quantity. And as you can see, after we grouped, we also have the sum, average, and total quantity. And finally, we'll be grouping multiple fields to show total sales throughout a different scenario. Over here, we selected a variety of things like year ID, s.year, and then we're going to order by city and year ID after grouping by year ID and city. So as you can see, we have year ID and city grouped together, and we have, once again, total sales, average sales, and total quantity. So that was a lot of examples that we went through, and I had to rush through them and go through them very fast because of our time constraint. But the idea of that was just to show you like the power and capability of what SQL can do, and like so you can get an idea of how simple it is to go through such a large database with SQL. So here are the next steps. SQL analytic functions such as row number, rank, partition by, etc., and getting more into the advanced functions. Primary, secondary, and foreign keys. Data security, providing table access to different database users such as grant, revoke. Transactions such as commit and rollbacks. So those were some of the things that you can explore within SQL, and of course, there's a lot more. And I want to thank you for attending this presentation. You can reach out to me at dhruv.rai@hsnavigator.org. And you can also connect to my LinkedIn, which I have on the slide. And thanks for watching. And once again, you can explore more SQL on ApacheFriends.org or SQLiteBrowser.org. They're free to download. And hope you guys have a great summer.